Okay, in this worksheet, please make sure that you have a periodic table. This is for polyatomic ions. On your periodic table, this is what it's going to, this is the portion of the periodic table you're going to be referring to. I want you to look at the charges here. Okay, that's a +1 charge. This is a -2 charge. -1, -1, -2. So if there's just a negative sign with no number like that, it's for a -1. So you don't have to memorize these, but they are named differently, okay? Remember ionic bonds yesterday I said ended in IDE? These are special and they end in ATE or ITE. Some are a little bit different, but you can always refer to this. So we're going to start with 1 through 6 on write the name of the ion. I'm going to do a few of these. It's really small there, so I rewrote them here for you. These are the same ones on your paper. And again, we're just going to be writing the names. So in a second. Okay, you refer to your polyatomic chart on the periodic table. That's all it says. Write the name, refer to periodic table, polyatomic chart. So if you guys understand, you can go ahead and get started. And if you need a little more guidance, let me help you. So OH, with that little negative sign, I refer to this chart. OH with the negative signs right there, I just write the name of it is called hydroxide. SO3, -2, I go to my chart. It's at the very, very bottom. SO3, -2 is called sulfite. I would write sulfite. NO3 with the charge of -1. I go to my chart, it's right there. NO3 with the -1 charge is nitrate. Is anyone not sure how to name these, where to find them? Do you want me to do more practice ones? Number 4. PO3, -3. It should be PO4. I felt funny writing that. So PO4, -3. So if there's any errors in the worksheet or you can't find it, just let me know and we'll see which one it needs to be corrected. Okay, so I'm going to leave those. I'm going to move to a different section in the worksheet. Okay, so right now, everything's so small. I just did that. Write the formula of the ion. Okay, I'm starting on number 7, ammonia. So I go to the periodic table on the polyatomic side. And it's right at the top. Ammonia is NH4 +1. You have to include that +1. Number 8, sulfate. Again, I go to the periodic table. I remember seeing the salts at the bottom. Sulfate's there. SO4, -2. And that's all I would write. Anybody have any questions on finding the formulas for those? Okay, so you just look at the periodic table. It's very, very easy. And you get to use the periodic table on your exam, so that helps. Okay, so I'm going to move on to 14. NH4Cl. Okay, so the NH4 would be ammonium. I spelled it wrong. And the Cl is chlorine, but we would do chloride. So this is where they're mixing them both in. You have a polyatomic, I spelled it wrong, guys, sorry. It's ammonium chloride. So it's using the polyatomic first and then just a regular chlorine. I'm going to have to write it on a separate sheet. So 15. Yeah. Okay, so SR on the periodic table. I look at my polyatomic chart first. There are no SRs on my polyatomic. Oops. There's no SRs. So then I'm going to flip it over. SR is anyone? Strontium. Okay, thank you. The strontium. And NO3-2 is, that will be on the polyatomic chart. Down there at the bottom, NO3 is going to be nitrate. Nitrate.
So since it has a subscript like under this next to the parentheses, what does that mean?
Okay, so think of the parentheses as they're pretty much untouchable. Okay, so what you're looking at is the NO3, that their family deal. It's a package. Okay, the 2 means you have 2 of them, and that's a really good question. So if I go back to SR, I know it has a charge of +2. Okay, and NO3, if I look at this polyatomic chart, NO3 has a charge of -1. Okay, I'm just gonna kind of split them.
So it's gonna have 2 there.
Exactly. So there's 2 of them. So the charge of this is -1. But the rule is they have to cancel out. Right now it's not equal. This has more. So I'm going to have 2 NO3 atoms in order to cancel out. Because now this is +2 and this is -2. Okay, so they cancel. But you'd still have to say that there's 2 of them. Because if anyone looked at this, you know, and just saw it without the 2, they're like, okay, I need 1 strontium atom and I need 1 nitrate atom. And let's say they're doing a reaction. Well, that's not going to work out well because you need 2 of them. So you always include the subscripts, like 2. If it's ever over 1, you include them. Okay? This is a side note. It's not on the worksheet, but let's just say it was going to my periodic table. Let's say it was this, and this is +2, and this is -2. You do not write it as that just because they cancel out. Okay, you would write it because whoever's reading this needs to know that you put 2. Okay, you put 2 atoms. Okay, that was a good question. So that would be the answer for, we were on number 15. Okay, I'm going to go ahead and do another one for you. Let's look at 16. It's just so tiny, I'm going to use the other sheet. Li is what? And OH, we already did this before. It's on the polyatomic ion side. OH is right here. So So it's hydroxide. And that's the answer. Okay, when you're writing formulas, that's where it's going to get a little bit more difficult, and you probably will need an extra sheet of paper because that's when you're going to have to be doing the canceling out to figure out how many atoms you really need to cancel out the charges. So, any questions on 14 through 20? Anything catch your eye? Okay, so let's start at 21. Potassium. I'm going to rewrite these so you guys can see them. I'll do 21 and I'll do 22. Okay, potassium carbonate. Potassium is K. That's on the regular side of the periodic table. Carbonate is on the polyatomic side. It's the third one. Okay, so it's CO3 -2. The CO3, they can't be separated. That's why I put it in parentheses. It's a package deal when you see it in parentheses. Do you put the charge? Okay, and the charge for potassium is, flip your periodic table around, +1. Okay, so how many potassiums do we need for it to cancel? You need 2, so it would be that. That says K2 CO3 1. You don't have to write the 1 though. So it's really just the same if you want to do the butterfly method. Like put the 2 to the K and the 1 goes to the CO3. I'll let you write that down. If you already did that, try number 22 by yourself and I'll get started in about 30 seconds. So your first step, if you're not sure, you find magnesium on the front of the periodic table, the normal side that we've been using. And then you find sulfate on the polyatomic side, which is on this side. And this is what you should have got. Just because they cancel out, again, doesn't mean you don't have to write them. Anyone have questions on how to name them? This is also called the butterfly method, if you hear me say that, because you're exchanging charges. So Mg used to have that 2, that went there. SO4 had that 2, it goes there. And again, you don't carry over charges.
That's where I'm confused at with the positive charges.
Okay, and the only reason Mg has a positive charge, like, oh, do I put positive or if I put negative, is because magnesium is a metal. So all metals are going to have a plus sign. And the only ones you need to know, and you can mark it on your periodic table, are the first 2 families. Anything in these 2 families is going to have positive signs.
Can you do the next one? Because
Okay, so +1 for this family one, +2 for this. And then over here, the negative signs, this is -1, -2,